Welcome to Hello World Academy, where we turn coding curiosity into coding mastery. In this exciting series, we're bringing you the top 100 Python interview questions and answers that will not only sharpen your skills, but also prepare you for your next big career leap. Whether you're a budding programmer or a seasoned coder, these carefully curated questions will challenge you, enlighten you, and give you the confidence to ace that interview. For those who love to learn at their own pace, we've got you covered. Grab the PDF version of all these insightful questions and answers from the video description. It's your personal cheat sheet to interview success. Stay tuned and make sure to download the materials, interact in the comments, and of course, hit that subscribe button for a continuous flow of tech knowledge. Your coding journey to success starts here at Hello World Academy. For any further inquiries or a dose of inspiration, reach out to us at info@helloworldacademy.com. Let's dive in. Question 1. What is Python, and why is it popular? Answer. Python is a high-level, interpreted programming language known for its clear syntax and readability. It supports multiple programming paradigms, including object-oriented, functional, and procedural programming. Python's popularity stems from its versatility, allowing it to be used across various fields such as web development, data science, automation, and more. Additionally, Python's vast ecosystem of libraries and frameworks, like Django for web development and Pandas for data analysis, makes it a preferred choice for developers. Its simplicity and readability make it accessible for beginners, while its power and flexibility attract experienced programmers. Now, let's move on to question 2, building on the foundation of Python's popularity. Question 2. Explain the differences between Python 2 and Python 3. Answer. Python 3 introduced several key improvements over Python 2 to enhance code readability and efficiency. Major changes include the print function, Unicode support by default, and changes in syntax and library functions to facilitate cleaner code. Python 3 also improved integer division to return a float for more accurate calculations. With Python 2's end of life, Python 3 is now the standard, offering more robust features and improved performance. Understanding the core differences between Python 2 and Python 3, let's consider how Python handles a crucial aspect of programming memory management. Question 3. How is memory management handled in Python? Answer. Python employs automatic memory management through garbage collection and a system of reference counting. This approach helps manage memory by deallocating objects that are no longer in use, thus preventing memory leaks and optimizing resource usage. Lastly, we will touch upon the data types that Python provides as built-in options for developers. Question 4. What are Python's built-in data types? Answer. Python includes several built-in data types, such as numeric types int, float, complex, sequences list, tuple, range, mappings dict, set, frozen set, and the Boolean type bool, along with the text type str for strings. These foundational types allow for versatile data manipulation directly in Python. Moving to question 5 on package management. Question 5. How do you manage Python packages? Answer. Python packages are managed using pip, Python's package installer. This tool allows for installing, updating, and removing packages from the Python package index PyPI. Virtual environments, created with tools like Venv or Virtualenv, enable isolated package installations per project to avoid dependency conflicts. Advancing to the concept of namespaces in Python with question 6. Question 6. Explain the concept of namespaces in Python. Answer. Namespaces in Python are symbolic dictionaries that map names to objects. They provide a way to ensure that names are unique in a program and prevent naming conflicts. Python uses namespaces to organize and manage the identifiers that are assigned to different objects, such as variables and functions. Let's now look at a Pythonic feature with question 7. Question 7. What is a list comprehension? Answer. List comprehension is a concise, efficient way to create lists in Python. It allows for the generation of a new list by applying an expression to each item in an iterable, optionally filtering items with a condition. For example, x2 for x in range 10, if x%2 equals 0 creates a list of squares for even numbers between 0 and 9. This method is more syntactically compact than using for loops to populate a list, making the code cleaner and often more readable. Next, we address error handling in Python with question 8. Question 8. How do you handle exceptions in Python? Answer. Exceptions in Python are handled using try-except blocks. This structure allows you to catch and respond to errors or exceptions that occur within the try block, preventing the program from crashing and enabling graceful error handling and recovery. Exploring the efficiency of iteration in Python, we arrive at question 9. Question 9. What are iterators and generators? Answer. Iterators in Python are objects that can be iterated over, one value at a time. Generators are a special type of iterator that lazily generate values on the fly without storing them all simultaneously, using the yield statement. This approach is memory efficient, especially for large datasets. We tackle the nuances of object copying in Python with question 10. Question 10. Describe the difference between deep and shallow copy. Answer. The shallow copy creates a new object, but inserts references to the objects found in the original. It's typically done using copy or objects built in methods like list for lists. This kind of copy is not fully independent. Changes to the original affect the copy and vice versa. The deep copy creates a new object and recursively copies all objects found in the original, resulting in a fully independent clone. It's done using copy and is necessary when the original object contains nested objects, and a full independence of the copy is required. Question 11. What is PEP8 and why is it important? Answer. PEP8 stands for Python Enhancement Proposal 8, which is a document that provides guidelines and best practices on how to write Python code. It covers naming conventions, code layout, indentation, and more, aiming to improve the readability and consistency of Python code across projects. Following PEP8 is important because it ensures a high level of code readability, making it easier for Python developers to understand and collaborate on code written by others. Adhering to these guidelines also helps maintain a standard in Python coding, which is beneficial for project maintenance and scalability. Next, we tackle the practicalities of script execution with question 12. Question 12. How do you make a Python script executable? Answer. To make a Python script executable, you need to do two things. First, add a shebang line at the top of your script file, such as #usabin python3, which tells the system which interpreter to use to run the file. Second, change the file's permissions to make it executable by running the command chmod +x script name py in a Unix or Linux environment. This allows you to execute the script directly from the command line by typing script name py. Now, let's discuss the versatility of function arguments in Python with question 13. Question 13. What are args and quargs, and when would you use them? Answer. Args and quargs are used in function definitions to allow passing a variable number of arguments. Args is used to pass a non-keyworded variable length argument list, while quargs allows you to pass keyworded variable length arguments. You would use args when you're not sure how many arguments might be passed to your function, making your function flexible in terms of input. Quargs is useful when you want to handle named arguments dynamically in a function. Question 14. Explain the use of the with statement. Answer. The with statement in Python is used for resource management and exception handling, ensuring that resources like file streams are properly cleaned up after use, regardless of whether an exception was raised or not. It provides a cleaner and more readable way to acquire and release resources automatically. For example, when working with files, using with to open a file ensures that the file is closed automatically once the block of code is exited, even if an error occurs. Question 15. What is the difference between == and is? Answer. The == operator checks if the values of two objects are equal, comparing the values stored by the objects. For example, list1 == list2 returns true if both lists have the same elements. The is operator, on the other hand, checks if two objects are identical. That is, if they are the exact same object in memory. For instance, list 1 is list 2 returns true if both variables point to the same list object. On to question 16, discussing string formatting in Python. Question 16. How do you manage string formatting in Python? Answer. Python provides several ways to format strings. The most common methods include %% formatting, which uses placeholders like %s and %d. The str format method utilizes curly braces as placeholders for variables, allowing for detailed formatting options. Formatted string literals, or f-strings, introduced in Python 3.6, offer a concise syntax for embedding expressions inside string literals, like f-hello name. F-strings are efficient and easy to read, making them the preferred choice for string formatting in modern Python. Next, we explore a compact function definition with question 17. Question 17. What are lambda functions? Answer. Lambda functions, also known as anonymous functions, are small, one-line functions defined without a name using the lambda keyword. They can have any number of arguments, but only one expression, the result of which is returned by the function. Lambda functions are used for short, simple operations within higher-order functions like map, filter, and sorted. An example is lambda x, x2, which is a lambda function that doubles the input value. Moving on to debugging techniques with question 18. Question 18. How do you debug a Python program? Answer. Debugging a Python program can be approached in several ways. Inserting print statements helps to display variable values at certain points. Integrated development environments IDs like PyCharm or Visual Studio Code provide built-in debugging tools with breakpoints, step-through execution, and variable inspection. The PDB module, Python's built-in debugger, allows for interactive debugging with commands to navigate through the code, evaluate expressions, and inspect variables. Third-party tools like IPDB and debugging tools integrated into frameworks can also facilitate debugging Python applications. Question 19. What are modules and packages in Python? Answer. Modules in Python are files containing Python code, such as definitions and statements, that can be imported into other Python programs. They help organize code into reusable components. Packages are a way of structuring Python's module namespace by using dotted module names, like package module. Essentially, a package is a directory that contains a special file in it. Py and one or more modules, allowing for organized, scalable code structures. Question 20. What does the pass statement do in Python? Answer. The pass statement in Python is a null operation. It does nothing. It's used as a placeholder in blocks where syntactically some code is required, but you don't want to execute any operation. For example, in defining minimal classes or functions, or within loops or conditionals where no action is needed, but you require the structure for future code. Question 21. Explain the difference between lists and tuples. Answer. Lists in Python are mutable, meaning they can be modified after creation, and are defined with square brackets. They are slower due to the flexibility of operations like addition, deletion, etc. Tuples, on the other hand, are immutable and cannot be changed once created. They are defined with parentheses and are faster as they require less memory due to their immutability. Tuples are preferred for read-only data and can be used as keys in dictionaries. Question 22. What is slicing in Python? Answer. Slicing in Python is a technique for accessing a range or subset of elements from a list, tuple, or string or any iterable using a concise syntax. Slicing is performed by specifying a start index and an optional end index separated by a colon, within square brackets. For example, mylist15 retrieves items from index 1 to 4, excluding the index 5. Python slicing also supports negative indices to start counting from the end and steps to skip elements within the slice. Question 23. What is the scope in Python, and how is it defined? Answer. The scope in Python refers to the region of a program where a namespace is directly accessible. In simple terms, The scope determines the visibility of a variable within the code. Python defines 4 types of scopes, often summarized as the LEG rule. Local L. The local scope refers to variables defined within a function. Enclosed E. The enclosed scope pertains to the outer functions in case of nested functions. Global G. The global scope is for variables defined at the top level of a script or module. Built-in B. The built-in scope covers names pre-assigned by Python. The scope is determined by where a variable is assigned in the code. This concept is crucial for understanding variable accessibility during the execution of code. Question 24. How do you implement unit tests in Python?
Answer.
Unit testing in Python can be implemented using the Unitest module, which is part of the Python standard library. To create unit tests, you define a subclass of Unitest test case, and then write methods within this class to test different aspects of your code's functionality. Assertion methods like assertTrue and assertFalse check for expected outcomes. To run the tests, Unitest main is called in your test file, which scans the test case classes and executes the test methods. Question 25. Explain Python's object-oriented programming OOP. Answer 25. Python's object-oriented programming OOP is a programming paradigm that uses objects and classes to structure software. It encapsulates data and functions within objects. In Python, everything is an object, including classes themselves. The OOP principles in Python include inheritance, allowing the definition of new classes from existing ones; polymorphism, using a unified interface to operate on objects of different classes; and encapsulation, hiding the internal state of an object and requiring all interactions to be performed through the object's methods. Question 26.
How does Python support multiple inheritance?
Answer 26. Python supports multiple inheritance, permitting a class to inherit features from more than one parent class. This enables the creation of a class with attributes and methods from multiple bases, providing design flexibility. Python manages the complexities of multiple inheritance through the method resolution order MRO, which defines the sequence-based classes are searched when executing a method. Question 27. What are metaclasses and how would you use them? Answer 27. Metaclasses in Python are classes of classes. They define the behavior and rules of other classes. While classes are templates for creating objects, metaclasses are templates for creating classes. They provide customization for class creation, useful for implementing specific patterns or modifying class properties automatically. Metaclasses can be used for enforcing coding standards, implementing singleton patterns, or automatically registering classes in a program. Now, let's jump to question 28 to understand the roles of class and static methods within Python classes. Question 28. Explain the use of class and static methods. Answer 28. Class methods and static methods are 2 distinct method types in Python classes that can be called without creating an instance of the class. Class methods, which are marked with the @classMethod decorator, automatically receive the class as their first argument, named CLS, allowing them to access and modify class state that applies to all instances. Static methods, on the other hand, do not receive an implicit first argument and are marked with the @staticMethod decorator. They operate like regular functions but belong to the class's namespace and are used for utility functions that don't access class or instance-specific data. Moving on, we come to question 29, where we look at how Python handles file input and output operations. Question 29. How do you manage file EO in Python? Answer 29. File input-output EO in Python is managed using the built-in open function, which returns a file object equipped with methods and attributes for operations like reading, writing, and appending. Python's context managers, often used with the with statement, ensure that resources are properly managed and files are automatically closed after their operations, preventing file corruption and leaks, which simplifies resource management. Next, in question 30, we'll explore the concept of virtual environments and their importance in Python development. Question 30. What is a virtual environment and why use one? Answer 30. A virtual environment in Python is a self-contained directory that includes a Python installation for a particular version, along with various additional packages. It allows developers to manage dependencies for different projects separately, avoiding conflicts between package versions and maintaining project-specific configurations without affecting global Python settings or other Python projects. Let's proceed to question 31 to discuss Python's handling of date and time. Question 31. How do you handle date and time in Python? Answer 31. Python manages date and time using the DataTime module, which offers classes for manipulating dates, times, and intervals. This module is versatile, allowing for operations like retrieving the current date and time, formatting dates and times in different ways, or calculating differences between dates. It also supports time zones, leap years, and other intricate aspects of the calendar, providing a comprehensive toolset for date and time manipulation. Continuing to question 32, we'll delve into the mechanisms behind context management in Python. Question 32. What is context management in Python, and how is it implemented? Answer 32. Context management in Python refers to the handling of resources like file streams or database connections, ensuring they are correctly acquired and released. This is done using context managers with a with statement, which encapsulates the setup and teardown logic for resources. This approach simplifies resource management by automatically handling exceptions and ensuring resources are cleanly released, even when errors occur. Question 33. How can you improve the performance of a Python application? Answer 33. Improving the performance of a Python application can be accomplished through a variety of methods, such as optimizing algorithms, using efficient data structures, utilizing compiled libraries like NumPy for numerical operations, and adopting concurrency with threads or asynchronous programming. Profiling tools are also instrumental in identifying performance bottlenecks. Moreover, implementations like PyPy, which includes a just-in-time JIT compiler, can offer significant performance enhancements for CPU-bound tasks. Finally, we reach question 34. Where we clarify the differences between class methods, static methods, and the @property decorator in Python. Question 34. What are the differences between @class method, @static method, and @property? Answer 34. In Python, @class method is a decorator that transforms a method into a class method. It receives the class as its first argument, named CLS, allowing it to access and modify the class state that applies across all instances. It's particularly useful for factory methods that need to know about the class to call other class methods or constructors. The @static method decorator converts a method into a static method, which doesn't receive an implicit first argument and behaves just like a regular function. However, it is included in the class's namespace. Static methods are used for utility or helper functions that do not access or modify class or instance-specific data. Lastly, @property is used to turn a method into a property, which allows it to be accessed like an attribute. This is ideal for when you need to control access to an attribute, perform additional actions on setting a value, or compute a value dynamically when it is accessed. Properties are a way to implement encapsulated data access and validation within the class structure. This concludes the explanation of these 3 Python decorators, which are essential tools for creating structured and maintainable object-oriented code. Having differentiated between class methods, static methods, and properties, let's now address question 35 to understand how Python deals with memory management and the strategies for handling memory leaks. Question 35. How do you manage memory leaks in Python? Answer 35. Managing memory leaks in Python involves identifying and resolving issues where the garbage collector is unable to reclaim memory from objects that are no longer needed but still referenced. Techniques include careful management of global variables, using weak references with the weakref module, and avoiding circular references or breaking them explicitly. Profiling tools like ObjGraph or TraceMalloc can help identify memory leaks by tracking objects and memory usage over time. For managing memory, let's proceed to question 36, where we will discuss the application of Python in the realm of web development. Question 36. Discuss the use of Python for web development. Answer 36. Python is a popular choice for web development due to its simplicity, versatility, and the rich ecosystem of web development frameworks it supports, such as Django and Flask. These frameworks provide libraries and tools that simplify tasks like URL routing, template rendering, and database interaction, making it easier to develop robust and scalable web applications. Additionally, Python's readability and concise syntax allow developers to build complex features with fewer lines of code, enhancing productivity and maintainability. Moving forward, question 37 will delve deeper into the web development frameworks Flask and Django, highlighting their key features. Question 37. What are the key features of Flask and Django? Answer 37. Flask is a micro-framework that is lightweight and flexible, with minimal default components, ideal for smaller projects or when more control is desired. Its key features include a built-in development server, integrated support for unit testing, and extensibility with numerous extensions for additional functionalities like ORM, form validation, and upload handling. On the other hand, Django is a high-level framework that is batteries included, providing a comprehensive standard library for common tasks and is suited for rapid development of large-scale applications. Its features include an ORM for database operations, authentication support, URL routing, a template engine, and built-in security features. After exploring Flask and Django, we will look into question 38 to understand how Python manages database connections, an essential aspect of back-end development. Question 38. How do you manage database connections in Python? Answer 38. Database connections in Python can be managed using different libraries depending on the database system, such as SQLite 3 for SQLite, PyMySQL for MySQL, or Scicop2 for PostgreSQL. The typical approach involves creating a connection object using the appropriate database driver, executing SQL commands through a cursor object, and committing changes to the database. It's crucial to properly close connections and cursors to avoid resource leaks. Context managers are often used to ensure that resources are automatically managed and released, even in the event of an error. Next, we'll transition to question 39 to examine the significant role Python plays in data analysis, which has become a cornerstone in today's data-driven world. Question 39. What is the role of Python in data analysis? Answer 39. Python plays a significant role in data analysis due to its simplicity, powerful libraries, and community support. Libraries like Pandas for data manipulation, NumPy for numerical computations, and Matplotlib for data visualization, along with machine learning libraries such as scikit-learn and TensorFlow, make Python a preferred choice for data scientists and analysts. Python's syntax is intuitive for data manipulation and exploration, and its interoperability with other tools and systems allows for seamless integration into data analysis workflows. Question 40. How do you ensure the security of a Python application? Answer 40. Ensuring the security of a Python application involves multiple strategies: validating and sanitizing input to prevent injection attacks, implementing proper error handling to avoid exposing sensitive information, using secure authentication and authorization mechanisms, encrypting sensitive data both in transit and at rest, and keeping Python and all dependencies up to date to mitigate known vulnerabilities. Additionally, adopting security frameworks and libraries designed for Python can help enforce security best practices. Understanding application security is crucial. Now, let's proceed to question 41, which discusses Python's significant contributions to machine learning and artificial intelligence. Question 41. Discuss Python's role in machine learning and artificial intelligence. Answer 41. Python plays a pivotal role in the development of machine learning (ML) and artificial intelligence (AI) due to its simplicity, versatility, and the extensive ecosystem of data science libraries and frameworks it supports, such as TensorFlow, PyTorch, Scikit-learn, and Pandas. These tools provide powerful functionalities for data manipulation, statistical modeling, neural networks, and deep learning, making Python the language of choice for researchers, data scientists, and developers in the ML and AI fields. With the prominence of Python in ML and AI established, let's look at question 42 to learn about the implementation of concurrency in Python. Question 42. How do you implement concurrency in Python? Answer 42. Concurrency in Python can be implemented using multiple approaches, including multi-threading, multiprocessing, and asynchronous programming. The threading and multiprocessing modules enable Python applications to run tasks in parallel, improving performance for IO-bound and CPU-bound operations, respectively. Asynchronous programming, facilitated by the Asyncio library, allows for writing coroutine functions that are executed concurrently, making it well-suited for IO-bound tasks that require high levels of scalability and responsiveness. Concurrent programming is a powerful feature of Python. Moving on to question 43, we will delve into asynchronous operations and their performance in Python. Question 43. What are asynchronous operations, and how are they performed in Python? Answer 43. Asynchronous operations in Python allow for non-blocking execution of code, enabling the program to handle IO-bound tasks more efficiently. They are performed using the Asyncio library, which provides a framework for writing asynchronous code using the async and await syntax. This approach is beneficial for building high-performance network applications, web servers, and handling concurrent IO operations without the need for multi-threading or multiprocessing, thus simplifying code and reducing resource usage. Having understood asynchronous operations, let's explore question 44, which addresses the global interpreter lock GIL and its impact on multi-threaded applications in Python. Question 44. Explain the global interpreter lock GIL and its impact on multi-threaded applications. Answer 44. The global interpreter lock GIL is a mutex in the standard Python interpreter CPython that ensures only one thread executes Python bytecode at a time. This simplifies memory management at the cost of true parallelism in multi-threaded applications. The GIL can be a bottleneck for CPU-bound applications that require concurrent execution of threads, leading to underutilization of multi-core processors. However, IO-bound applications, or those using multiprocessing, which involves separate memory spaces, are less affected by the GIL. From concurrency, we transition to network programming. Question 45 focuses on how Python is utilized for network programming. Question 45. How do you use Python for network programming? Answer 45. Python is extensively used for network programming due to its powerful standard libraries like Socket, which provides a low-level networking interface, and higher-level options such as requests for HTTP operations. Python's simplicity and readability make it ideal for developing network applications, including clients, servers, and network tools. Libraries such as Twisted for event-driven networking and Asyncio for asynchronous IO further facilitate the development of efficient network programs. Networking is one of the many applications of Python. Lastly, question 46 will guide us through the concept of type hints in Python and their role in code maintenance. Question 46. What are type hints, and how do they improve code readability and maintenance? Answer 46. Type hints in Python are a feature introduced in PEP 484, allowing developers to indicate the expected data types of function arguments and return values. While Python remains dynamically typed, type hints enhance code readability by making the intended use of variables and function signatures clearer to other developers. Additionally, they facilitate better maintenance and error detection through static code analysis tools, improving development workflows and reducing the likelihood of runtime errors. Now that we've addressed the use of type hints for improving code readability and maintenance in Python, let's move to question 47 to understand how Python integrates with other programming languages. Question 47. Discuss the integration of Python with other languages. Answer 47. Python offers extensive capabilities for integration with other programming languages, enabling developers to leverage libraries, frameworks, and performance advantages where needed. This integration is commonly achieved through several methods. C++ extensions can be created using tools like Cython or CFFI, allowing Python to interact with C++ code and optimize performance. Python can also use COM objects or DLLs on Windows directly. The foreign function interface FFI through libraries like ctypes allows Python code to call functions in dynamically linked libraries. Furthermore, inter-process communication IPC techniques like sockets or message queues enable Python applications to communicate with applications written in other languages, enhancing interoperability. With our understanding of Python's interoperability, let's proceed to question 48 to explore the various strategies for optimizing Python code for performance. Question 48. How do you optimize Python code for performance? Answer 48. Optimizing Python code for performance involves a multifaceted approach, choosing the most efficient algorithms and data structures, profiling and benchmarking to identify bottlenecks using tools like cProfile and Timeit, utilizing Cython to compile Python to C for critical sections of code, or employing the PyPy interpreter, which includes a JIT compiler, and implementing concurrency with multiprocessing or Asyncio for parallel or asynchronous execution. Additionally, minimizing resource usage, such as reducing memory footprint and EO operations, can significantly enhance execution speed and program efficiency. After considering performance optimization, we turn to question 49 to discuss best practices for testing in Python, a critical part of developing reliable and robust applications. Question 49. What are the best practices for testing in Python? Answer 49. Best practices for testing in Python emphasize the importance of writing testable code and maintaining a comprehensive suite of tests. Utilizing the Unitest or PyTest frameworks helps write unit tests that cover individual components. Integration testing ensures that different parts of the application work together as expected. Test-driven development (TDD) is a practice where tests are written before implementing functionality to guide the development process. Mocking and patching with Unitest Mock can control the behavior of external dependencies, and continuous integration side tools like Jenkins or GitHub Actions automate testing against every change in the codebase, ensuring quality and preventing regressions. This comprehensive approach to testing ensures that Python applications are as bug-free as possible and maintain the highest standards of quality. Question 50.
How do you manage large-scale Python projects?
Answer 50. Managing large-scale Python projects requires careful planning and organization. Version control, using tools like Git to track changes and collaborate effectively. Code review, implementing a code review process to maintain code quality and share knowledge. Modular design, structuring the project into modules or packages that can be developed, tested, and deployed independently. Virtual environments, using Venv or Virtualenv to manage project-specific dependencies. Automated testing and SICT, establishing a robust testing framework and automating deployment processes. Documentation, maintaining clear and up-to-date documentation for developers and users. Project management tools, leveraging tools like Jira or Trello to track progress, manage tasks, and coordinate team activities. These strategies help streamline development, ensure product quality, and manage complexity as projects scale. Question 51. How do you implement polymorphism in Python? Answer 51. Polymorphism in Python allows different classes to be treated as instances of the same class through a common interface. This is achieved by ensuring they share the same method names and attributes. Python implements polymorphism through duck typing, where the object's actual type is less important than the methods or attributes it possesses. For example, by defining a method speak in both a dog and cat class, you can iterate over a list containing both dog and cat objects, calling the speak method on each without knowing the object's type. Question 52. Explain encapsulation with examples in Python. Answer 52. Encapsulation in Python involves bundling data and methods that operate on that data within a single unit, a class, and restricting access to some of the object's components. This is primarily achieved through the use of private variables and methods, denoted by prefixing the name with an underscore. For example, in a bank account class, the account balance can be encapsulated as a private variable self balance with public methods like deposit and withdraw to modify it safely, ensuring direct access is controlled. Question 53. What is inheritance, and how is it used in Python? Answer 53. Inheritance is a mechanism in Python that allows a class to inherit attributes and methods from another class, known as the base or parent class. This facilitates code reuse and the creation of hierarchical class structures. Inheritance is implemented by defining a new class that includes the name of the parent class in parentheses. For example, if you have a vehicle class, a car class can inherit from it using class carVehicle, allowing car to use the methods and properties of vehicle while also adding its own. Question 54. How do you create a class in Python? Answer 54. Creating a class in Python involves using the class keyword followed by the class name and a colon. Inside the class, methods are defined as functions, with the first parameter typically named self to refer to the instance. Now, moving on to question 55. Let's delve into the significance of the self parameter in class methods. Question 55. What is the significance of the self parameter in class methods? Answer 55. The self parameter in Python class methods is a reference to the current instance of the class. It is used to access variables and methods associated with a current object. It allows class methods to modify the object's state and to call other methods on the same object. The self parameter must be the first parameter of any method in the class, but it is not passed explicitly when the method is called. With the concept of self explained, let's progress to question 56 to understand how private methods and variables are created in Python classes. Question 56. How can you create private methods and variables in Python classes? Answer 56. Private methods and variables in Python classes are created by prefixing their names with two underscores. This name mangling is a convention to prevent access to the method or variable from outside its class. For example, miprivate variable and miprivate method would be treated as private and intended to be accessed only within the class itself. After discussing private methods and variables, let's turn to question 57 to explore method overriding in Python. Question 57. Explain method overriding in Python with an example. Answer 57. Method overriding in Python allows a subclass to provide a specific implementation of a method that is already defined in its superclass. This is done by simply defining a method in the subclass with the same name, parameters, and return type as the method in the parent class. Here, a child class overrides the show method of parent. When show is called on an instance of child, it prints inside child, demonstrating overriding. Continuing our discussion, in question 58, we'll see how Python supports method overloading, or rather, its approach to it. Question 58. How does Python support method overloading? Answer 58.
Python does not support method overloading in the traditional sense found in some other programming languages, where multiple methods can have the same name but different parameters. Instead, Python allows for a single method to handle different types or numbers of arguments using default parameters or variable length argument lists, args for positional arguments and quargs for keyword arguments. This approach provides flexibility, enabling a function or method to be called with different numbers of arguments, effectively simulating method overloading.
In question 59, we'll discuss abstract classes and their usage in Python. Question 59. What are abstract classes, and how do you use them in Python? Answer 59. Abstract classes in Python are classes that cannot be instantiated and are designed to be subclassed. They typically contain one or more abstract methods, which are methods declared in the abstract class, but must be implemented by the subclass. Abstract classes are used to define a common interface for a group of subclasses. Python provides the ABC module abstract base classes to facilitate the creation of abstract classes. You use them by inheriting from ABC and decorating methods with that abstract method to indicate they are abstract and must be overridden in non-abstract subclasses. Question 60. Explain the concept of composition vs. inheritance in Python. Answer 60. Composition and inheritance are two fundamental concepts in object-oriented programming in Python. Composition implies a has a relationship where a class includes instances of another class as attributes, promoting better modularity and flexibility. It's ideal for cases where objects are made of other objects without a clear hierarchical relationship, enhancing encapsulation by bundling related functionalities in separate objects. In contrast, inheritance denotes and is a relationship. A subclass inherits from a superclass, gaining its attributes and methods. It's a way to establish a hierarchical relationship between classes, facilitating code reuse. However, inheritance is less flexible once the hierarchy is established, and changing it can be difficult. It also risks weakening encapsulation if subclasses rely too much on the superclass's implementation details. Moving forward to question 61, we will delve into the usage of the super function in Python classes. Question 61. How do you use the super function in Python? Answer 61. The super function in Python is used to access methods from a superclass in a subclass that inherits from it. This function is a cleaner and more maintainable way of accessing the superclass's methods without explicitly naming it, which is especially useful in supporting cooperative multiple inheritance. Typically, it's used within the init method to ensure that the superclass is properly initialized. It also allows a subclass to access overridden methods from the superclass that might have been shadowed. Next, let's look at question 62 to understand the role of mixins in Python. Question 62. What is a mixin, and how can it be used in Python? Answer 62. A mixin is a class that provides methods to other classes, but is not intended to be standalone. In Python, mixins help modularize and reuse code across multiple classes, allowing for the sharing of functionality without establishing a strict parent-child relationship. They are included as base classes and other classes to introduce specific functionalities in a flexible and reusable manner. As we grasp the utility of mixins, let's proceed to question 63 to distinguish between class variables and instance variables. Question 63. Explain the difference between class variables and instance variables. Answer 63. Class variables are shared across all instances of a class, defined within the class declaration and outside any methods. They have a class-wide scope, meaning the same value is accessible to every instance of the class. Modifying a class variable affects all instances. Instance variables, however, are unique to each instance of a class and are defined within methods, typically within the init method using the self keyword. They have a scope limited to the specific instance, and modifying one instance variable does not affect other instances. With these concepts clarified, let's now turn to question 64 to understand how dynamic attributes are managed in Python objects. Question 64. How do you manage dynamic attributes in Python objects? Answer 64. Dynamic attributes in Python objects are managed using the setattr, getattr, and hasattr functions. Setattrobj, name, value is used to set an attribute on an object to a specified value. Getattrobj, name, default retrieves the value of a named attribute, and hasattrobj, name checks for an attribute's existence. Moreover, Python's dict attribute represents an object's attributes in a dictionary form, allowing for direct manipulation and management of attributes dynamically. Question 65. What are magic methods in Python? Give examples. Answer 65. Magic methods, also known as dunder methods from double underscores, are special methods in Python that provide hooks into built-in behavior. They are identified by their double underscore prefix and suffix, like init for object initialization and str for defining a human-readable string representation of an object. Examples include add for the plus operation, iter for iteration support, and enter and exit for context management. These methods allow developers to define how instances of a class behave with respect to language constructs like iteration, context management, arithmetic operations, and more. Let's jump to question 66. How do you check if an object is an instance of a particular class or subclass? Answer 66. To check if an object is an instance of a particular class or subclass in Python, you can use the built-in functions isInstance and isObclass. IsInstanceObject classinfo checks if an object is an instance of a class or a tuple of classes, while isObclass classinfo checks if a class is a subclass of another class or a tuple of classes. These functions are instrumental in ensuring that objects and classes adhere to expected interfaces or hierarchies, especially in polymorphic designs. Moving on to question 67. Explain the concept of a class factory in Python. Answer. A class factory in Python refers to a function or method that dynamically creates and returns class definitions. Class factories are useful when you need to generate multiple classes that share similar structures but have different values or behaviors. By using functions to parameterize the creation of class definitions, you can increase code reusability and flexibility. For example, a class factory can take parameters defining class attributes and methods and return a new class tailored to those specifications. Now, let's tackle question 68. How can you dynamically create classes in Python? Dynamically creating classes in Python can be accomplished using the type function, which is a built-in metaclass. Type can be used not only to determine the type of an existing object, but also to create a new class on the fly. It accepts 3 arguments: the name of the class, a tuple of base classes for inheritance, and a dictionary containing attributes and methods. Question 69. What are slots in Python classes, and why would you use them? Slots is a special attribute in Python classes that defines a fixed set of attributes the class will have, preventing the creation of any new attributes. This can lead to significant memory savings when creating many instances of a class, because it avoids the overhead of a per-instance dictionary. Using slots is beneficial in situations requiring the creation of millions of instances of a class where attribute management is well-defined and static, improving performance and reducing memory usage. Question 70. How do you implement custom container types in Python?
Answer.
Implementing custom container types in Python involves creating classes that define methods for container behaviors, such as item access, iteration, and length reporting. Python provides special methods like getItem, setItem, deleTem, iter, and len that you can define in your class to support container operations. By defining these methods, your class can behave like standard containers such as lists, dictionaries, or sets, allowing for intuitive interaction and integration with Python's built-in functions and syntax. As we expand our Python knowledge, let's explore question 71. What are Python's scientific computing capabilities? Answer. Python's scientific computing capabilities are extensive, largely due to its powerful libraries and tools that facilitate numerical computations, statistical analysis, and data processing. Libraries such as NumPy provide support for large, multi-dimensional arrays and matrices, while SciPy offers modules for optimization, linear algebra, integration, and more. Together with other tools like Pandas for data manipulation and analysis, and IPython for interactive computing, Python serves as a cornerstone for scientific computing, enabling researchers and data scientists to perform complex analyses efficiently. Continuing our journey, we arrive at question 72. How do you use Python for data visualization? Python offers several libraries for data visualization, making it simple to create a wide range of static, interactive, and animated visualizations. Matplotlib is the most widely used Python library for creating plots and graphs. For more interactive visualizations, libraries like Plotly and Bokeh allow users to create web-based dashboards directly from Python. Additionally, Seaborn, built on top of Matplotlib, provides a high-level interface for drawing attractive and informative statistical graphics. Let's delve into question 73. What is the role of Python in cybersecurity?
Python plays a significant role in cybersecurity due to its simplicity and versatility. It's widely used for developing scripts and tools for penetration testing, network scanning, vulnerability analysis, and forensic investigations. Python's extensive library ecosystem includes frameworks and modules specifically designed for security tasks, such as Scapy for packet manipulation or the Python Cryptographic Authority's packages for encryption. Its ability to integrate with other tools and systems makes it a preferred choice for cybersecurity professionals.
We address question 74. How do you automate tasks using Python? Answer. Python is a popular choice for automating repetitive tasks due to its readability and the powerful standard library. Tasks such as file manipulation, web scraping, data entry, and network interaction can be automated using Python scripts. Libraries like Selenium for web automation, requests for HTTP requests, and Pandas for data manipulation enhance Python's task automation capabilities. Writing Python scripts to automate tasks can save time, reduce human error, and increase efficiency. Question 75. Discuss Python's package management and distribution tools. Python's package management and distribution are facilitated by tools like pip for package installation and Virtualenv for creating isolated Python environments. Pip interacts with a Python package index PyPI to download and install packages. For project-specific dependencies, Virtualenv allows developers to create isolated environments to avoid version conflicts. More recent tools like Poetry and PyPenv combine dependency management with environment management, streamlining the workflow for developing and distributing Python packages. These tools help manage libraries and dependencies efficiently, ensuring consistency and reproducibility in Python projects. Now, let's move to question 76. How do you ensure code quality and readability in Python? Ensuring code quality and readability in Python involves adhering to the PEP 8 style guide, which provides conventions for writing readable Python code. Using descriptive variable and function names, adding comments and docstrings to explain code behavior, and keeping functions and classes short and focused on a single responsibility also contribute to readability. For code quality, leveraging tools like Pylint, Flake 8, or Black for static analysis and auto-formatting can help identify and fix potential issues. Additionally, incorporating code reviews and writing comprehensive tests, using frameworks like PyTest or Unitest ensure that code not only meets functional requirements, but is also maintainable and error-free. Continuing on to question 77. What is the event-driven programming model in Python? The event-driven programming model in Python revolves around monitoring and responding to events, actions, or occurrences detected by the program, such as user interactions or system-generated events. This model is commonly used in GUI applications and web servers. Libraries like tkinter for desktop applications or frameworks like Twisted and Asyncio for asynchronous, networking support event-driven programming by allowing developers to register callbacks or use coroutines to handle events, facilitating the development of responsive and non-blocking applications. Next up, question 78. How do you handle state in a Python application? Answer. Handling state in a Python application can be achieved through various approaches depending on the application's architecture and requirements. For simple scripts, global variables or class instances stored in memory might suffice. In more complex, stateful applications, especially those with user sessions or data persistence needs, state management might involve storing state information in databases, using caching solutions like Redis, or leveraging session management in web frameworks like Flask or Django. For distributed systems, ensuring consistent state across components may require using message queues or shared databases with transactions or eventual consistency models. Question 79. How does Python integrate with containerization technologies like Docker?
Python integrates seamlessly with containerization technologies like Docker, enabling the creation of lightweight, standalone, and executable software packages containers that bundle Python applications along with all their dependencies. This integration is typically managed through a Docker file, a text document containing all commands needed to assemble the Python application's Docker image. Developers can specify the base Python image, install dependencies using pip, copy the application code into the container, and define the command to run the application.
This approach ensures consistency across development, testing, and production environments, significantly simplifying deployment and scaling of Python applications. Question 80. Discuss the most common design patterns used in Python and their applications. Answer. Design patterns are essential frameworks for addressing common problems in software design. In Python, we often use patterns that take full advantage of its dynamic nature and object-oriented features, such as the singleton, factory method, observer, strategy, decorator, and command patterns. Question 81. What is Pandas in Python, and how is it used in data analysis? Pandas is an open-source library providing high-performance, easy-to-use data structures and data analysis tools for Python. It's widely used for various data manipulation tasks, such as filtering, aggregating, and merging data, thanks to its powerful DataFrame object. Pandas simplifies the process of handling missing data, time series data, and performing complex data transformations, making it an indispensable tool for exploratory data analysis and data preprocessing in Python. Having explored Pandas, a library that enhances Python's data analysis capabilities, we now compare it to another foundational Python tool. Question 82. Explain how NumPy differs from Python's built-in lists. NumPy arrays are homogeneous and of fixed size, leading to high performance on numerical operations due to fixed type and contiguous memory allocation, supporting vectorized operations ideal for scientific computing. In contrast, Python lists are heterogeneous and of dynamic size, suitable for general-purpose programming where flexibility is required. From data structuring, we move on to address the issue of data quality. Question 83. How can you handle missing data in a Pandas data frame? Pandas provides several methods to handle missing data in data frames, including dropna to remove rows or columns with missing values, and fillna to replace missing values with a specific value or statistical measure like mean or median. Additionally, Pandas allows for more sophisticated imputation techniques through the interpolate method or integration with the scikit-learn library for more advanced imputation strategies. With our data now prepped and polished, let's discuss how to standardize it for machine learning models. Question 84. Describe how you would perform data normalization using scikit-learn. In scikit-learn, data normalization can be performed using the standard scalar or minmix scalar classes among others. Standard scalar standardizes features by removing the mean and scaling to unit variance, while minmix scalar scales features to a given range, usually between 0 and 1. This process involves fitting the scalar to the data using the fit method, and then transforming the data with a transform method, which can be combined using the fit transform method for efficiency. With our data normalized and ready for modeling, let's explore a library that's at the forefront of machine learning development. Question 85. What is TensorFlow, and how does it contribute to machine learning development? TensorFlow is an open-source library developed by Google for numerical computation and machine learning. It provides a comprehensive ecosystem of tools, libraries, and community resources that allows researchers to develop and deploy machine learning models efficiently. Its flexible architecture allows for easy deployment of computation across various platforms, making it suitable for a wide range of tasks from research to production in areas like deep learning, neural networks, and predictive analytics. Question 86. What are the main features of the Flask web framework? Flask is a lightweight WSGI web application framework in Python. Its main features include a built-in development server and debugger, integrated support for unit testing, RESTful request dispatching, and uses Jinja 2 templating. Flask is designed to be flexible and easy to extend with numerous extensions available for adding features like database integration, form validation, upload handling, and more. Moving on from the Flask framework's capabilities, let's discuss how it handles routing. Question 87. How do you manage URL routing in a Flask application? URL routing in Flask is managed by using the @AppRoute decorator to bind functions to a URL. You can specify variable parts in a URL by using angle brackets, allowing the function to accept dynamic data as input. Flask supports building URL dynamically and ensures that URLs are unique and SEO-friendly. Now that we understand URL routing, let's delve into another core feature of Flask, its decorators. Question 88. Explain the use of decorators in Flask. In Flask, decorators are used to wrap routes and view functions to modify their behavior without changing the code inside the functions. Common uses include URL routing at AppRoute, registering custom error pages at AppErrorHandler, and login required functionality at Login Required. Decorators provide a concise and readable way to add functionality to Flask applications. Having covered decorators, we'll now look at how a popular web framework interacts with databases. Question 89. How does Django's ORM work with databases? Django's ORM object relational mapping allows developers to interact with databases using Python code instead of SQL queries. It translates Python classes models into database tables and converts function calls into SQL queries, abstracting the complexities of SQL. This enables developers to perform database operations efficiently without writing raw SQL, supporting a wide range of database operations from simple queries to complex joins and aggregations. After exploring Django's ORM, let's shift focus to the scalability of web applications. Question 90. How do you scale a Python web application to handle high traffic? Scaling a Python web application to handle high traffic involves a multifaceted approach. Horizontal scaling. Distribute the load across multiple servers using load balancers. Caching. Implement caching with tools like Redis or Memcache to reduce database load. Database optimization. Optimize queries and use indexes to improve efficiency. Asynchronous processing. Handle time-consuming tasks asynchronously with Celery. Microservices. Break down the app into microservices for independent scaling. Content Delivery Network CDN. Serve static content via a CDN to reduce server load. Monitoring and auto-scaling. Use monitoring tools to dynamically adjust resources based on traffic. Code optimization. Profile and optimize application code to ensure efficient resource use. Moving on to question 91. Let's delve into optimizing operations with one of Python's powerful libraries. Question 91. How can you improve the performance of a pandas operation on a large dataset? Improving the performance of pandas operations on large datasets can be achieved by optimizing data types using a stype to convert columns to more efficient types. Using categorical data types for string variables with a limited set of values, employing vectorized operations instead of applying functions row-wise, chunking data during processing, and leveraging the eval and query functions for efficient computations. Additionally, using libraries like Dask for parallel computing can further enhance performance. As we consider data efficiency, let's turn to question 92 to understand a fundamental concept in array operations. Question 92. Explain the concept of broadcasting in NumPy. Broadcasting in NumPy refers to the ability of NumPy to perform arithmetic operations on arrays of different shapes, automatically broadcasting the smaller array across the larger one without duplicating data. This allows for efficient element-wise operations and aligns dimensions of the arrays by expanding the shape of the smaller array to match the larger one, enabling operations that would otherwise require explicit reshaping or looping. Advancing our discussion to machine learning, question 93 tackles a crucial step in model preparation. Question 93. How do you select features for a machine learning model using scikit-learn? In scikit-learn, feature selection can be performed using techniques like variance threshold for removing low-variance features, select best or select percentile for selecting features based on statistical tests, and recursive feature elimination RFE for recursively removing features and building a model with the remaining attributes. These methods help improve model performance by eliminating irrelevant or redundant features. Speaking of machine learning, TensorFlow's dataset API plays a vital role, as we'll see in question 94. Question 94. What is the purpose of TensorFlow's dataset API? TensorFlow's dataset API is designed to provide a fast, flexible, and scalable way to create complex input pipelines from simple, reusable pieces. It allows for the efficient handling and preprocessing of large datasets, seamless integration with TensorFlow models, and optimization of data loading by leveraging parallel processing and prefetching. The API supports a variety of data formats and sources, enabling efficient data manipulation and transformation for training machine learning models. Question 95 brings us to an important challenge in deep learning models. Question 95. How can you prevent overfitting in a deep learning model? Preventing overfitting in deep learning models involves techniques like regularization L1, L2 regularization, dropout randomly setting a fraction of input units to 0 at each update during training, early stopping halting training when validation performance degrades, and data augmentation increasing the diversity of the training set. Additionally, using a simpler model architecture or increasing the dataset size can also help mitigate overfitting. Question 96. Describe how you would deploy a machine learning model developed in Python. Answer. Deploying a Python-developed machine learning model typically involves steps like model serialization, saving the model using libraries like Pickle or Joblib, choosing a deployment platform e.g. Flask app, Django, AWS, Google Cloud, or Azure, containerizing the app with Docker for consistency across environments, and finally, setting up a REST API for model inference. Monitoring and versioning are crucial for maintaining the deployed model. Question 97. Answer. A pipeline in scikit-learn encapsulates a sequence of data processing steps like data transformation and model fitting into a single scikit-learn estimator. Pipelines streamline the workflow, ensuring that all steps are executed in the correct order. They also help in avoiding data leakage during cross-validation by ensuring that data transformations are only learned from the training data. Question 98. How do you visualize data in Python using libraries like Matplotlib and Seaborn? Data visualization in Python using Matplotlib and Seaborn involves using these libraries' functions to create a wide range of static, animated, or interactive plots and charts. Matplotlib provides a low-level interface for creating basic graphs like line charts, bar charts, and scatter plots, while Seaborn offers a high-level interface for creating more complex visualizations, focusing on statistical models. Both libraries integrate well with pandas for efficient data handling. Question 99. What are the limitations of Python, and how can they be addressed? Python, while versatile and widely used, has limitations such as slower execution speed compared to compiled languages, due to its nature as an interpreted language. This can be addressed by using performance-enhancing libraries like NumPy for numerical computations or Cython to compile Python code to C. The global interpreter lock-GIL limits the execution of multiple threads in a single process, which can be mitigated by using multiprocessing instead of multi-threading, or leveraging implementations like Jython or Pipey that don't have a GIL. Additionally, Python's dynamic typing can lead to runtime errors. Type annotations and thorough testing can help ensure type correctness. Question 100. What are the ethical considerations when using Python in data science? Answer. Ethical considerations in using Python for data science encompass issues related to data privacy, bias in machine learning models, and transparency of algorithms. Ensuring data privacy involves adhering to regulations like GDPR and anonymizing sensitive information. Addressing bias requires scrutinizing datasets for representativeness and employing techniques to mitigate bias in algorithms. Transparency is about making algorithms interpretable, so stakeholders understand how decisions are made. Ethical data science practice in Python necessitates a conscious effort to design systems responsibly, considering the impact on individuals and society. Thank you for watching our interview questions and answers series. We hope you found it informative and helpful for your learning journey. You can dive deeper into the world of programming with our courses by visiting our website at www.helloworldacademy.uk for more tutorials. And if you have any inquiries, please don't hesitate to reach out to us at info@helloworldacademy.uk. Remember, you can download the PDF format of all the questions and answers from the description of the video. Please don't forget to subscribe to our channel for more content and videos like this. Thank you again for joining us, and we look forward to helping you code like a pro.